Okay, I told Mrs. Ferrante, this is Mr. Toaz, that I would help her kind of explain to you how to find the area of a regular polygon. Um, she is trying to find her voice. You know, she's lost her voice. So I'm lending her mine, and hopefully we can get through this and you kind of see where we're headed with this. Not a difficult thing. All right, basically, we got a regular polygon in letter A here. We have a nonagon, nine-sided figure. And basically, we are going to be using the formula that area equals 1/2 the apothem times the perimeter. And um, you know, if you're not sure what the apothem is, we'll look at that here in the diagram in a second, and I think I'll bring all this together. Certainly, we know perimeter. Now, we know here we have a side length of 8. Each of these are 8. And we're going to do a couple things. One of the first things you want to do is put the center in and draw the central angle. Now, the central angle, it goes from the center to consecutive vertices. Now, this is a nonagon, so there would be, basically, that forms that nice isosceles triangle there. There would be 9 of those that would make this the nonagon. 9 of those triangles would make up the area. And basically, that's what that formula right underneath there does. Um, is it finds the area of one of them, and because you're multiplying the perimeter, which is 9 times that, you're going to, just get the total area of the regular polygon. So, first thing, another one of the first things you're going to do is find the central angle. Now, the central angle is that picture right there, that upper vertex of the isosceles triangle. And basically, we did that formula yesterday, or put it in our notes yesterday. It's 360 over n. In this case, n is 9 because this is a nonagon. So 360 divided by 9 is 40 degrees. So you have a 40-degree angle as a central angle. Now, I am going to put in the apothem. The apothem is the distance from the center to one side. And that, when we talk about the distance, we're talking about perpendicular distance. So we create a right triangle right there. And it also bisects that side. What I'm going to do now, you see it's created a right triangle. I'm going to enlarge that so it's easier for us to work with. So let me find a right triangle. I know this is lying on its side here. Let me just flip it up. Okay. All right, so this is that right triangle, and basically what you see is this down here is going to be 4 because it's half of the side length. This is going to be the apothem. Now, I didn't label it on right next to the red dotted line on the main diagram, but I will. And we have that. Now, we also know that the upper angle in this right triangle is half of the central angle. We said the central angle was 40, so that's going to mean this right here is 20 degrees. Okay, it's a 20-degree angle. And so because this is a right triangle, we can do some trig to find out what A is. So if you look at that right triangle, you see from the view of the 20-degree angle, perspective of the 20-degree angle, you have the opposite and adjacent sides. So that's going to be tangent. The tangent of 20 degrees equals the opposite side is 4, the adjacent side is A. So we're going to solve this now for A. So A is going to equal 4 divided by the tangent of 20. Basically multiplying both sides by A and then dividing by the tangent of 20. Now, when you do that, you should get around 11.0. Okay, so our apothem is about 11. And that's really all we need, because now if you look at that formula under our nonagon, it was area equals 1/2 the apothem. I just found it. That's 11 times the perimeter. Now, we haven't really named the perimeter yet, but I think we all can see what that is going to be. The perimeter is going to be 9 sides times each of them being 8 centimeters is going to be 72 centimeters. So our final area is going to be 1/2 apothem was 11.0 times the perimeter, which is 72, and that is going to be around 396 square centimeters. And that is your area for that nonagon. So really not all that crazy. Um, Again, you're using the central angle and the apothem to create a right triangle where you can use some trig. And we found that the tangent, looking at that bigger kind of blown up right triangle, the tangent of 20 equals the opposite 4 over the apothem A. Solve for A, get that to be 11. The perimeter in this problem, because they gave you side lengths, very simple, 9 times 8 and 72. Pop those into the equation, and you found your first area for a regular polygon. Okay? Very good.